Hi, good morning. My name is Anudeep, and today I'm presenting my Capstone project for DSC-672, and this is my software presentation for that. And this project is really close to my heart because it blends with three domains which I actually enjoy, which are the natural language processing, personalization, and user assistance. And the result is an AI-powered chatbot that can handle the documents, the PDF documents, for now and recommend movies and generate the diet plans, actually the personalized diet plans, all in one system. So let's get started. So coming to the intro, users today expect more from chatbots rather than just single question to answers, and they want the intelligence, relevance, and personalization. My solution is a modular chatbot that intelligently routes each query to the correct module. It uses cutting-edge libraries and frameworks to ensure responses are accurate and meaningful. And the chatbot is built to understand the context of queries and respond accordingly, no matter the domain. And coming to the next slide, so the LangChain, which I used in which we used in our project. So LangChain is a popular framework used in my project to build the applications with language models. So I used its PyPDF loader module to extract the text from the PDFs, and this allowed me to perform the document question answering efficiently. It integrates well with other tools, which made LangChain perfect for my document Q&A module. And this is all about the LangChain, and this is about the Hugging Face, which I also used for the PDF thing in my project. And coming to the Hugging Face is like a Google of the transformer models, you can say that. I use the Hugging Face models for two main things particularly. The first one is for creating the embeddings for the document chunks, and the second one is for using those embeddings in the question answering chain. These models make it possible for the chatbot to understand the user questions in a very understandable way. And coming to the next slide, so FAISS. So what's this? What does it stands for? So this is actually developed by Facebook AI. Phase. It's a high performance library for vector similarity search. After converting the text to the embeddings, I use the phase to index and retrieve the most relevant pieces. This is what powers the accurate, fast questioning answering uh, thing which I do for the with the use of the PDF documents. And this is all about the phase, and let's go to the next slide, which is the problem statement. So what's the problem statement? So my problem statements, problem statement is the fragmentation. The most chatbots are domain specific, one for documents, one for health, one for entertainment, all that. Even I've seen many chatbots like that. So my goal was to build one chatbot that could dynamically identify the user's intent, whether it's for the documents use or it's for the diets or for movies, and give useful tailored responses. So this is all about the problem statement. And coming to the architecture view, so the chatbot's logic is handled in a way that it actually identifies what's the user input, what he's asking regarding the entertainment, or he's asking for the diet, or he's asking for the document Q&A. So based on based on the logic, it just gives a response. So that logic is actually handled by the chatbot response function, which I'll be discussing it further in the code. And it identifies the keywords in user input and directs the request to the correct modules. And the three modules which we have in our project is a PDF Q&A, Guide Planner, and Movie Recommender. Each module has its own technique, from LLMs to cosine similarity. Everything is unified in one architecture actually. So let's go to the next slide, which is all the required libraries for our project. So our project in this, we used a combination of LNP, machine learning, and utility libraries. Langchain and Hugging Face and Face Power, the document Q&A, which is shown it earlier. And we use the sentence transformer and question similarity. And PyPDF2 handles the PDF parsing, and pandas, NumPy are used for the data manipulation. So this is all about the libraries which are used and their uses in our project. And coming to the next slide. So the PDF question answering. So let's walk through the PDF Q&A flow now. A user uploads a document first and he just asks a question. So the PDF is loaded, embeddings are generated and stored in the phase. Then based on the user's question, the most relevant chunks are retrieved and passed to the language model for the final answer. This is how the whole process is for the PDF Q&A. And coming to the next slide, PDF Q&A sample. So let me show you the code over here. So this is the code which we have right now, and we'll be working on it to make it more better. But for now, I've just taken a sample PDF which consists of data regarding the movies and the directors and its cast, etc., and the storyline. So what does this code does actually? Here we can see this code snippet. It actually shows the process for loading the PDF, creating the embeddings, and retrieving the relevant text chunks. And the final step is to we use a Q&A chain to generate the answer. It's modular and efficient. Any document can be used without retraining the system. That's the best part of it. So here we can see I've just put the PDF over here under the PDF path variable, and I've just asked multiple questions. So the best thing is it's not like only one question. You can give a multiple questions and get all the answers regarding it. So yeah, I've just given two questions. What is the story of the movie Parasite, and who is the director of the Inception? So these are the two basic questions which I've given to this, and it has given good answers, which is exactly which is exactly the perfect thing regarding the PDF which I've uploaded. And this is all about the PDF Q&A code sample. And let's go to the next slide, which is the movie recommendation. So the movie recommendation, this one, it uses sentence transformers. It converts the user preferences like scientific thrillers like Interstellar or Inception, something like that, into the vectors. It does it. These are compared with a pre-embedded movie dataset using this cosine similarity. It's fast and the recommendations are highly relevant. So in further updates, I'll be explaining more about it. So for now, we have just created a function, a sample function for the recommending movies. So here we can see this code block shows how user preferences are encoded and matched with the movie vectors. It uses the pandas to manage the dataset, and it returns the top 5 closest matches. This is completely dynamic and can be scaled to thousands of movies. So the dataset which we are using actually is a movie lens dataset. Here we can see how we have used the cosine similarity and getting the top 5 similarities based on the user input. So this is all about the movie recommendation logic. And coming to the next slide, which is the time plan generation. So here we can see the time plan generation. This particular function, it takes the user matrix like be it the age, height, and the goal, and also the gender, and what are their BMRs. So, and based on it, it estimates the daily calorie needs. So based on it, it says a balanced intake of the protein, carbs, and the fats, particularly the macros, you can say. So it's simple yet effective, and it can be adjusted based on the activity level. So what our intention is, when the user gives their age, weight, height, and their BMR, and what's their goal, So let's say if I've given my goal is as like muscle building, if I give that, so accordingly it just gives us recipes. I mean the food what you have to eat daily, and which totals the calories which you need to take every day. So based on it, it can also suggest the workouts according to the user input. So this is how we are actually planning to make the diet plan generation even more better. And so here we can see the sample code snippet which we are working on it right now. So this is how the diet logic works. It actually calculates a BMR, adjusts for activity level and goal, then allocates some macronutrients as I said earlier. You'll see that it creates a tailored daily plan without needing an external API or dataset. That's the thing which we are doing right now, and everything is computer live. So coming to the next, this is all about the diet plan code and the function which we have written. And coming to the next slide, which is the chatbot response function, which is the main function for the whole project. So the user this is where the user actually enters his input. So based on the user input, it just suggests the be it a diet, movie, or any PDF Q&A. So this is a whole flow for that, and this is the brain of our chatbot. So the chatbot response module over here, we can see it checks what the user is asking for and routes the query. So this is what the chatbot offers. For now, there are like three things which we are dealing with. One is the diet recommendation, movie recommendation, and the PDF Q&A. So which covers like three sectors. Diet comes under the health, and movie entertainment, and PDF coming to the educational thing. And coming to the next slide, which is testing the chatbot. So I tested multiple cases actually till now, asking for movie suggestions. Like so, movies are coming to the movie suggestions. There are like two ways. One way is like you can just ask based on the genre. Like I want to watch, just suggest me some thriller movies. It just gives you a list of the thriller movies. And you can also search in a way that you can just say I just watched Interstellar, so can you please recommend the movies which are like closely similar to the Interstellar. It does that too. And we've been training it a lot and testing with multiple questions, so the chatbot responded correctly in each case, and this validated the logic behind the routing and performance of each module which we are working on already. So coming to the next slide, the challenges. So no project I can say that it's without the challenges. I had trouble extracting the clean text from PDFs with varied formats, ensuring high quality embeddings, and tuning model parameters was also so tricky, which me and my team we spent a lot of time for that. And the final challenge was really a great query routing, which I resolved through keyword matching and pre-parsing. And these are the challenges which we faced. And coming to the next slide, which is like the applications. So this chatbot can actually serve the students with document Q&A, help fitness enthusiasts, and plan their meals, as well as the movies for the entertainment. It can also be intended for internal document searches in enterprises or product sessions in the e-commerce too. And coming to the next slide, the conclusion. So to conclude, this project shows that with the right tools, you can build an intelligent assistant that adapts to different needs. It's a unified platform that merges natural language processing, recommendation systems, and the data science. And it also uses the open source tools, which makes it reproducible. So I want to conclude in this way, and coming to the next slide, what are the next steps we're gonna do. So this is the best part actually, which me and my team we are excited a lot regarding it. So we're gonna add the Streamlit based GUI so that the users don't have to write their code. I also want to support. I also want to include the supported scanned PDFs using the OCR and allow the feedback collection so that the bot learns from the user interactions and evolves over time. So we are planning all this to make it possible. Uh, should be by the next update, we should be putting it in our code. And coming to the next slide, yeah, thank you. So this project was really a very good experience for me and from my team, and I hope it inspires us to build something similar. So yeah, that's all. Thank you.